Hey y'all, how's it going? So today, kind of the first lesson that we're getting into is picking up kind of where we left off. We kind of last finished talking about motor efficiency and how we can do that and control motors. And if you were on a B-Day, you start actually building these VEX test beds, which I have one right here in front of me. Boom, look at this bad boy. And so today, what we're going to kind of talk about is essentially how to be a robot, right? And kind of, I started this off, I sent you guys that question. I really enjoyed reading you guys' responses, pretty kind of thoughtful and thorough. But like if a robot can have these motors and these sensors, what's like the human equivalents, right? What do we use to sense the world around us? Well, it's our senses, right? We have sight, we have smell, we have hearing, we have touch, we have taste, right? And those are our sensors, right? At the fundamental level, those are kind of different kinds of sensors that we have, and they're in different parts of our body. For example, like touch is like all over, sight is only in the eyes, scent is only in the nose, so on and so forth. We have these ways to actually sense and perceive things in the real world, right? And then we can process those and react to those. And the main way that we kind of react, the motors that we have, would be our muscles, right? At the largest scale, that's really the main one that we have. There's also other ways where we can like release hormones or those kind of things and release things into the bloodstream. But the main thing that we're going to really consider are muscles, right? So we can use our muscles to drive speech, right? To drive motion, to lift things, to move things, and that's that, right? Now, one last thing that we kind of have that ties both of these things together is our brain, right? So we have these complex neural pathways that connect all of our sensors, all our sensory organs, right, to our kind of motor system, our muscles, right? So if I get an input, if I put my hand on like or if I put my hand on a hot stove, for example, and it starts to get warm, right? I sense that, can sense the heat. And I get that sense, it goes up to my brain, and my brain processes, oh, it's really warm, and it tells my arm to move, right? Actually, in that case, it doesn't even go to the brain. It's more reflexive, which is a little interesting. But let's say, yeah, it's like someone's like pinching me. It's like I can move. Or I see like a car coming my way. My brain, that signal goes up to my brain processes that and gives me an output, which says essentially, fire these muscles and run out of the way. Okay. So that's how humans can work. And these robots are exactly the same. Right? So what I want to start off today with is just like a little overview of these different kind of pieces to our robot that we have, these different kind of organs, inputs and outputs that we can have and what they do and what they look at. And then we're going to get into kind of how we can communicate with this thing and how we can talk like a robot. So let's go ahead and start. I'm going to kind of move this around and hopefully set it up to where we can kind of see this test bed. We'll see how I can do. That's pretty good, right? Kind of good, kind of okay, maybe. A little closer. All right. Boom shakalaka. So here's like kind of the base of our test bed. You guys may have seen this if you guys want kind of like a cleaner view of what it looks like. It should look something like this, right? We had these build instructions and you get something that looks like this. If I go back to full screen, just a little bit of a rundown as to what we have here. Here we have our motors, right? And these are just basic motors. Are called left and right motor because one's on the left and one's on the right. And these kind of, we went over and talked about them. And essentially, if we run an electric current through them, they can start to spin, right? These are our muscles. Now, a similar, and then we can use these, we can take that electrical energy, those electrical impulses, and turn them into motion, which is essentially what our muscles do. We can take this one form of energy and convert it into motion. Now, this guy here is actually a servo motor. It's attached to this little gear here. Now, servos are kind of neat because they turn specific distances. Right, so this guy can go, I think it's 120 degrees, right, from one way to another. So it doesn't actually even go a full half circle, right? It goes 120 degrees. But it's very useful because I can set it to a precise position, whereas the motors, right, I can't actually necessarily do that. I can run them for a set period of time and at a set speed, right? The speed is kind of determined by the current I send through that motor, but I can't set them to a specific position. In the servo, you can do that. So servos become very useful if you want something at a specific position, right? So those are kind of our outputs. The one other output that we'd have would be the flashlight here, right? Just like 4 LEDs in there, and if we run a current through this, then we can turn on light. Similarly, we just have this little tiny green LED here, which is similar. We can turn that on and off by sending a signal to it. So then we can go into our inputs, right? Our sensory pieces. So the first one I'll go over is this. Oh geez, what is this called again? Has a specific name that I'm blanking on. Ultrasonic Rangefinder, right? This guy right here. So this guy, it actually sends out one of these is an output speaker, right? And one of these is an input. And there's actually some labels here on the side where these wires come out. And so it sends out a sound wave, right? That's actually inaudible to us, for us to be able to hear, but it sends out a sound wave and it travels. And let's say that there's an object here above it, right? It bounces off this object above it and then comes back down in to this other side and it picks it up. Because the speed of sound is relatively constant in air, with slight fluctuations based on temperature and density, it can calculate how far away something is, right? So I believe that this can see things up to 250 inches away, if I'm not mistaken. It can sense those, but it has this kind of cone that it sends out. Okay, so that's this guy. This can tell how far away something is using kind of sonar. And once again, it's like we have these wires that kind of go out and they signal to tell this guy to fire, and they read that signal as well. Next piece that we have here, this is a potentiometer, right? This little fella. And this you can spin and you can set to a specific range, right? So let's say this is 0, and I can turn this all the way around. It's not a full 360. It's like 270 degrees or something, right? But I get a range of numbers, essentially, a range of values that I get by turning this, right? And the way this works is it's a variable resistor, right? And it has a wire that kind of goes to my cortex that tells me essentially how far it's turned, how much resistance is this little device experiencing, or does it have, because it sends a signal in from here, and then it has a certain amount of resistance, and so a certain current comes back. And the robot can kind of pick that up, and it'll give me a value that it's set at. So this is useful if I want to, I could use this to control the speed of my motor, right? I could tie that to this. And so if this thing's turned, if it's sensing like a certain amount of turns or a certain position, right, then it can respond to that. This next guy is a Quadrature Encoder, right? This is just a free spinning thing. And what it is on the inside of this little box here, there's essentially a little circle thing that has has 360 little slits in it. And there's a little light that goes through here, and it counts how many times the light gets blocked by those little slits. Or rather, the light gets let through by those little slits. And so if I spin this one full spin, it counts 360 of those slits being passed, right? And so this can actually count how many degrees something is turned, right? So if I want something to only spin like 2 full circles, right, this can measure how many spins something has done, right? Which is pretty incredible. And it's just using light passing through. So actually within here, we'll go ahead and talk about one of our next sensors, which is the light sensor over here, right? This little guy, it's got this little dollop there. And this can actually sense light coming through it. So how much light's coming in. So it gives you a range of values from essentially very bright to very dark, right? So this can actually sense how much light is going through. So if I had something like this Quadrature Encoder, if I had one of these inside there, and I shone a light at it, like with my flashlight, right, then this could pick up how much light it's actually receiving. Okay. Other ones, we got this line follower or this line tracker. This essentially it picks up changes in contrast. It works kind of similar to this guy, but it's a little bit different. We don't use these quite as often, but they do definitely have some use still. But this can picture changes in contrast. So if I have like a white line on a dark background, this makes it really easy to kind of follow. And this guy works by essentially sending out a light wave and picking back up how much is reflected back, right? So as this guy is just picking up the light coming in, right? This guy is sending out, it's kind of like the rangefinder, and it sends out a light wave and it records how much is coming back. So how much is being reflected versus how much is being absorbed, and then sends a signal back. And then we've got our button. It's kind of nice. It just records how many times it's pressed, right? Every time it's pressed, essentially that completes the circuit, and it records that it's happened. And then this is a bump switch, or sorry, this is a limit switch, which does essentially the same kind of thing, right? So I can record like the number of times that something's touched, or if this gets like pushed. So this is useful because if I have something that's kind of spinning and it closes this, right, that can tell me that, you know, I've essentially felt something, right? These really can be the feelers of your robot, right? If you want it to feel that something is like touching it, then you can set these up to where it can say, hey, something's here, go ahead and like stop or do something else or start this motor. Okay, and that's about it. Now, each one of these has a wire, right, that is connected to my central circuit. So just like every muscle is connected to your brain, right, all of these through your nervous system, right, these wires essentially connect to the brain of the whole thing, which is this VEX cortex, right? And everything has a specific spot which we've put it into, and that's important for when we start to program our brain, right? So that's the overview of what we have here. And like I said, this is just so important because, right, when we talk about making these robots or these autonomous things, this is the system that we're working with, right? And this is what we have. So thinking about kind of how these things work, right? This guy here, thinking about this brain, this complex circuitry is really what this is. Just like, you know, those kind of breadboards that we had like on steroids. And when I put these pins into a certain port, it's like completing the circuit in one way and routing it one way. And there's some really complex circuitry in here that allows signals to come in and be rerouted and all sorts of cool stuff. But this is essentially the brain. Just like, you know, if I touch this part of my hand, that sends a signal through my nervous system, which is like my wiring for my body, up to my brain. My brain processes that. My brain has really complex circuitry in its nervous, as that part of the nervous system. There's a big density of neurons. There's like this big web, this cloud, and it can take that signal and then use it to generate some kind of like an output, right? So this guy, depending on how we set it up, it can take signals, right, and give outputs, right? So I could say something like, hey, you know, if I press this limit switch, I want you to turn on this left motor, right, at half speed, right? And then when I press the bump switch, I want you to stop. Okay, and so we can actually code for these behaviors in our robot. Okay, so that's an introduction to what we have. Now, part of how we do that, right, is, like I said, into our brain, we plug these into a very specific spot, right? And we can choose that. This is something that we can actually set up for any robot that we're encoding, is we choose where things go. There's some sensors that are analog, right? And this has to do with the signal that they create. So these create a kind of a range of signals, right? Whereas the digital ones just give us like a number, right? Like a number. And they count specific numbers. And so that's a slight difference. You got to make sure if it's an analog sensor, it goes into the analog inputs. If it's a digital, then it goes into the digital, right? The LED is also a digital kind of output there. And then we have our motors, which is variably controlled. And so those go into the motor outputs. Those include the flashlight, the right and left motor, and then the servo motor, right? So we can send a variable signal to those, whereas these just give us like, it's a hard like yes, no, on, off. Okay, so everything has a specific spot where it can go, and we can plug those in. And this is kind of a chart that we can use to keep track of where we put everything. And that's important because when we actually go to code, right, in Robot C, which is what we would be using to actually code this, and we'll be doing some practice on this next time. But we can go to our motor and sensor setup, and we can actually look, and in our motor setups, which correspond to the ports that we have here, right, we've got 10 motor ports. Well, here we have 10 motor ports, and depending on where we put them, they're all labeled on our cortex. I can name them, right? So I've named the port 1, and I'm named flashlight, and it's a Vex flashlight, right? So on and so forth. The sensor is the same thing. Sensor port, analog sensor port 1, I named line follower, and it's a line follower. Right? I could add another one and call it, let's say I want to add another potentiometer. Maybe I call it potentiometer 2, okay? And I say it's a potentiometer, right? So that's the way that that's done. And we can set that up, and then we can use this to actually kind of train our robot. You know, just like you have your genes, you have your brain, you have this system that's developed. And then through your experience, you learn certain responses and certain reactions. Well, we can train this robot, right? We can give it some general context and background to know how to act through code, right? We set up the physical connection, and then we use the code to kind of teach it how to think, right? Or how to react or how to respond, which is going to be kind of cool. Now, in order to do that, in order to code our robot here, so there's a few pieces. Number one, we need to have this physical setup, right? Just like you have a physical setup. And the second part is we need to kind of teach it. We need to be able to communicate and explain to it how to interact with the world around it. And in order to do that, right, we need to think about how to talk to a robot, right? And robots are not necessarily like the smartest of things. They can be trained to be quite smart, but really at the base level, the actions that they do are very simple. It's like, how many times was this button switched? How many times did this thing turn, right? What value of light am I sensing? And based on those simple inputs, they can do certain things. They can turn on a motor for a certain period of time. They can set a servo motor to a certain position. They can turn on a flashlight at a certain brightness, right? But there are these simple little things that they can do. Right? They're not complex motions. Now, we can coordinate a bunch of those simple motions to create a complex task, but we need to plan for that, right? The robot can only understand one kind of thing at a time. And so what we're going to talk about today, and this is the final piece that you guys are going to turn in, is how we can actually create a flowchart. This idea of this sequence and process-based thing to understand and communicate a complex task using a bunch of simple tasks. Right? So this is the first step. So this is the way it is. This is what a flowchart is. You guys may have seen these before, and it's just a schematic representation of this process, right? So for example, if we're trying to feed a dog, right? So there's always a start. You check, is the dog bowl empty? Yes, the question here, if it's empty, yes, pour food into the bowl and then stop. If it's not empty, then you just stop. And that's it, right? So we've taken that process and we've broken it down into a bunch of simple steps. Now there's a few parts that you can kind of label, and these are standardized. I'll actually kind of show you guys in Google Sheets. They're used kind of across the board. These represent a start or an end. This little tablet thing, a square or rectangle is a process, right? So this is something that you do, right? An input or an output is something that's either put in or read or stated. It's like a button being pressed or like a number being entered. A decision is like a question, right? And it has to be a yes or a no question. Okay, it cannot be like a complex question. It has to be a yes or no question. So if you ever played 20 questions, you have to ask yes or no questions. This is the same kind of thing. Use arrows to connect them, and then this is display. If you want something like displayed, for example, you can do that. So, and I'll post this on Classroom Set. So you guys can check that out a little bit more. But here's an example that you guys can do. So let's say we have a task that we want to do. We want to count from 1 to 9 by odd numbers. So just 1, 3, 5, 7, 9. Stop. Right. So that's what we want the output to be. Right. Is we want the output to be 1, 3, 5, 7, 9. And we're going to start with the start block always. Right. And so what's the first thing that we're going to want to do in this case? Well, in this case, right, we want to start with the number 1. Okay, that's our first number. That's our starting point. Okay, so we want it to have 1. So we're going to start with 1. And then now, right, we want to actually say that number. So we actually have this task. So we have our input here, input 1. And we have our task, say number, right? So that'd be like, let's say you push a button once, and then you say 1. Or you type in 1 and then the computer says 1. Okay. Then we're going to continue this. So what we want to do is if we want to go from 1 to 3, right? So a simple way to do that is we just add 2. So instead of saying input 1, say number, input 3, say number, and just having it work once, we just say input 1, say that number, and then we add 2, right? We're counting by odds, right? So this is a way to kind of to simplify our flow chart so that it requires less steps than programming everything individually, right? So then we're going to add 2. That's a process. And then we're going to add in a question, right? So if the number is greater than 9, right, then we're going to have something. But if it's not, if we haven't reached 9 yet, then you're going to go back. You're going to say the number that you get. You're going to add 2. You're going to ask that question again, right? So this, what we've added in here is what's called a feedback loop. Okay, so we have a process. We've done something, and then now we have a question. We have a consideration, right? We're sensing to see, right, is the thing that we're getting greater than this value? If not, we're going to keep doing this thing. If it is, right, then we're going to end. So if it's greater than 9, that means that we're done. We're not going to say that number anymore. So if we think through how this would work, okay, so we input 1, say 1, add 2, right? Our new total is 3. Is that greater than 9? No. So we say 3. We add another 2, we get 5. Is that greater than 9? No. So we say 5, so on and so forth until we get to 9. We go back up, right? We say 9, we add 2, we get 11. That is greater than 9, so then we end. So we would have said 1, 3, 5, 7, 9, right? So this is the kind of process that we're looking at here, and this is the kind of thinking that we can do. Now, could I have done this another way? Yeah, 100%. I could have made it just, input 1, say number, input 3, say number, input 5, say number, input 7, say number, input 9, say number, end. But that would not be as elegant or as simple of a code or as versatile, right? Let's say I wanted to count to 21 in odd numbers. Then that would be a lot longer versus this. I just change one thing. Okay, so thinking about how can you add in these loops or these processes, these repetitive things to continually check and monitor. I mean, that's what our bodies are doing all the time is we're continually checking and monitoring the environment around us through our sensors, through our sensory system to determine what we need to do. Okay, so these are very, very useful kind of loops that you guys can do. Consider questions in your flowcharting. And what I want you guys to do, and this is your homework, is you're going to create a flowchart that shows how to pour a glass of milk. Okay. Now you're going to picture that the glass is on a table in front of you, and the milk is in a fridge, which is about 20 feet to your left. Okay, so just to kind of simplify that situation, the glass is on the table in front of you. The milk is in a fridge that's 20 feet to your left. Okay, so think about what you need to do. Now, once again, simple actions. This has to be composed of simple actions. So can you just start by grabbing the milk? No, right? You need to move over to the fridge to get the milk, right? Can you just reach into the fridge and grab the milk? No, it's like you need to open the door first. So think about trying to be as detailed as possible, right? How do you know when to stop? How do you know when to stop walking towards the fridge, right? Considering how are you continually sensing, right, the worlds that you can break this up into as finely detailed of actions as possible, right? Really, in a lot of ways, the more detailed, the more basic actions you can do, the better. It's like a step would be a basic action, right? But you can also sense. You can sense like, is the fridge less than 1 foot away? Right? Let's say you have like as a person like an ultrasonic rangefinder, you can sense a little bit of a distance. Okay, so think about the sensors that our robot has, and think about what you have, and kind of tying those together when you're flow charting, right? Trying to make it so that you're not doing anything that your robot couldn't necessarily do, right? That's the idea. Now you can either draw this by hand, or if you guys want to, this is what I would personally recommend. I think it's a little bit neater, is if you can create a new Google drawing, right? You can title it whatever you need. Let's say like it's milk. Okay. And what I can do is I can actually insert these different shapes. And actually here in the shapes, there are, right here, there's all these different flowcharting things, right? So we have our process, we've got a decision, we've got input or data, and we have our start and stop. So let's say I want to start with my start. I can just double click in here and say start. Right? And let's say that I want my first kind of process. I can go ahead and draw my shape. And my first process is going to be let's just call it simple. Let's say stand Seems pretty straightforward. And then I can just add these together with arrows, and tie them together. And then what's nice about this is then I can move this, and then they're kind of linked together, right? So I can kind of arrange this as I see fit. Now, one thing that you'll a lot of times see with these flowcharts is they'll kind of go left to right, and then they'll kind of go back down and around and keep going. Another nice thing with this is I can kind of stretch this as I see fit. To kind of stretch my canvas for this, right? And that's the idea. I can always zoom out and make it a little bit bigger or smaller to work for me, right? So that's the idea. That's what your guys' kind of homework is. I've attached a little presentation on the introduction, kind of going over the different parts of the robotics platform that you guys kind of need to know. You can peruse that as you have your leisure. I'll attach this on there, and that's that. So yeah, hope the virus has been, this quarantine has been going so well that you guys are getting outside having some fun. And yeah, I'll see you guys next time.